share my screen and we can start with what we have for today. Okay, so I believe if you can all see this my screen that I'm sharing, can you please indicate? So I'll be sure that I'm doing what's right.
Yes.
Okay, that's fine. So good day, everyone. I am Akalonu Chukwuzie Blaze. I'm a software developer and a beta Microsoft student ambassador. And according to our schedule, today we're going to be treating machine learning basics with Azure ML. So I would like you guys to buckle up and listen attentively as we have a reasonable amount of stuff to speak about. And if you have any questions or wish to draw us back at any point in time, you can just signify on the group or notify one of the facilitators. Also, like drop a message in the chat. I'll be paying close attention to it to answer anyone's questions. So without wasting any more time, let's go straight into the next slide. Okay, so first of all, this is a women, gender, minorities in tech Azure AI bootcamp. So it means it's centered to train you all about artificial intelligence, its applications, and all we can use it for. But then it wouldn't really make any sense to treat AI without talking much about machine learning, as it's the heart of where artificial intelligence systems are developed and built. So first, we have to ask ourselves first, what is machine learning? So we can say machine learning is a subset of artificial intelligence that focuses on building systems that learn or improve performance in making decisions based on data consumed without being explicitly programmed. Now, when one can ask, what does being explicitly programmed mean? So it's basically the concept of machine learning was developed when computer scientists observed that computers struggled when it came to decision making or areas where human intelligence was required. So it's very easy to tell a computer, do this. If this condition exists, do this, else do that, right? But then when you have a scenario where there are 1,000 array of conditions or scenarios available, and then the conditions or parameters required are not as clear as possible, what do you do then? It's actually dates back research. Then the concept of artificial intelligence was developed in computers, and as artificial intelligence continued to develop, machine learning became the heart of artificial intelligence. So instead of following hard-coded instructions, as you can see here, machine learning algorithms are trained to identify patterns and then make decisions based on the data they are fed. And this is very important because we can see it in basic object identification, computer vision, natural language processing. That you could snap an apple and feed to a computer and say, hey, this is an apple, let's say a green one. And then when you feed it a red apple, it may not identify it as an apple. It would call it something else. So the essence of data is being able to supply the computer with a large array of different variations so that a computer can be trained to understand and identify a particular object scenario, understand what you are saying in the cases of speech, natural language processing, and recognition to improve artificial intelligence. So it's a sub and superset thing. AI is the broader umbrella, and machine learning is a smaller branch that's at the heart and core of artificial intelligence. So we now move to the main types of machine learning. And okay, you ask yourself, what are the types of machine learning? Because in every new technology or scenario, there's always like different types with patterns to understand and execute what you're working on. So we basically have supervised learning, unsupervised, and reinforcement learning. Well, if you go to a couple of research papers or try to read online or to multiple articles and websites, you would see up to 4 or 5. But based on the fundamentals and my knowledge, I would just stick to these three, right? So you now begs to ask the question, what's the meaning of these three different types of machine learning that we call the main types? So supervised learning is basically training a computer to take labeled inputs and map it to known outputs. So kind of like the example I gave earlier where you take a picture of 1,000 apples and feed it to a computer and say, okay, learn the different shapes, the different colors, what different apples look like, so that when the time comes, you can show the computer any type of apple or a machine learning model and to be able to identify it for you. So it's supervised because we already know the output and we have the input. We already know it's an apple, right? We are training it to identify an apple. So it's called supervised learning in this note. So machine learning models that are designed to do tasks that we already have the output, but we're just training them so that they can now automate tasks for us in in areas where we need automation. That's where the real strength of supervised learning comes in. So you do well to take notes. If you have any questions, you can ask, but this is basically the summary of understanding what supervised learning is. Then you have unsupervised learning. So unsupervised learning is basically when you train a computer to understand patterns and trends in data and then discover the output. So it's basically like training a computer to develop a trading algorithm or to understand the stock markets, something that we're not sure of the exact output. But we already know that with the right data and parameter given to it, the computer would develop an output that would have a high accuracy, at least 99 up to 99.99% accuracy. That is, if possible. Most models are usually um, efficient within 60 to 90%. We can categorize as very good output in most cases, right? So this is basically how unsupervised learning works. Now the next is reinforcement learning. Reinforcement learning is almost like a reward based scenario. I would give an analogy for this first of all. It's kind of like teaching a child, it's kind of like training a child to learn and understand a particular concept while rewarding him when he or she does the right thing and giving a certain level, I wouldn't say punishment, but to reprimand someone when he or she does it wrongly or to notify the person that, hey, this is wrong. So reinforcement learning is reinforced basically through an iterative method until the machine or model gets it right. So when it gets it right, it's rewarded in based on like tokens and whatever method seen fits. But I know it's usually rewarded on a token based basis. And then when it doesn't get it right, you go again for reinforcement and try to feed in the data and parameters to get the exact output or something close to what is required, right? So you have supervised, unsupervised, and reinforcement learning. So these are the three main types of machine learning methods. If you go online to the internet and try to Google some other methods, you may see some other types of machine learning methods, machine learning types that are there, but I just want to focus on the three, right? So the next thing we're going to look at now, we've spoken about the three main types of machine learning, is why machine learning? Why? Because it's very simple to just speak about these concepts that are very, very complex because they sound very nice in the ear. You say machine learning, machine learning. With the new trends in technology, we all have that one friend or person we know that mentions machine learning at the slightest instant. There have even been like jokes and comedy about it in like tech companies where there's like, hey, can we implement this with machine learning? But it's not exactly how it works. So machine learning can automate complex tasks, right? In the areas of identifying patterns that are that would naturally require human intelligence. So the reason why we train computers to gain artificial intelligence through machine learning is because they are not naturally intelligent. We're trying to make them intelligent artificially, and that is by feeding them data by force. They can't do it on their own. So when computers are trained through machine learning models, they are able to perform automated tasks. Um, I will give I will give examples. I will give examples right after this, but I will continue to mention and speak on them. Next is improved decision making. Now, this is something I've already spoken about, right? But it was common knowledge to computer scientists before the adaptation of machine learning that computers were bad at making decisions, right? Especially when it wasn't straightforward, without an if and else scenario or conditional, right? So machine learning now, through its different methods, supervised, unsupervised, and reinforced, can enable computers take smarter decisions because they can now um, run what they see or the inputs given to them by data they have been trained on, instead of just going for straight binary conclusions in ones and zeros. So it improves decision making in areas where would human cognition or intelligence would have been required naturally. Now, on a computer can now perform such tasks and do it well, right? Then improve personalization tasks. We've seen advancements in this area mainly in the areas of e-commerce, personalization of products, services, and so much more. Even learning parts on e-learning applications now. I think I took a course on data camp not too long ago, and the AI was able to adapt to the learning patterns of the students when they failed, when like I would go through exercises and not get them right the first time. It found out, it was able to try and personalize the way it presented the answers, right, as a way of correcting. So personalization tasks are important because models can be trained to understand what learners understand from understand better with and feed it directly to them and then let them work with it. Exactly. So next is handling large scale data. We already know that computers have the higher computing ability compared to like our regular human brains, right? Or even with regular computerized systems. So improving the decision making of computers definitely makes it easier for them to handle large scale data, as they can now take decisions and then process data accordingly, rather than in scenarios where they would, let's say, handle the large scale data, but then not perform it correctly because the decision making of computers were very bad. Then we can talk about adaptability, the ability of systems to easily adapt from what they are expected to do normally to something else. So machine learning models continuously improve and learn from data, making them flexible and scalable for solving problems, right? So if you build a machine learning model to solve a particular problem, the parameters for that particular problem may be static at the instant you develop it. But then at certain points in time, it may require varying parameters. I'll give an example. You could develop a model to predict the best routes to avoid traffic in a city, where and then train it based on data and the plyage of the roads through known busy routes and the rest. But then a single occurrence in a particular event during a particular period can change the parameters for this particular routes training. So, for example, if there is a major construction going in a part of the city and now makes that particular area unplayable, whereas it would normally be perceived as a free route that a model would recommend. Through real-time data real-time data pipelines are fed to machine learning models. They can learn to adapt to this particular through this particular data that is fed to them, predict and recommend new routes, and also map out new areas in the process. So this is a very good example of adaptability in machine learning models. So one thing you have to understand when talking about machine learning, which I know most people will know, but I still have to speak about it again, is that the heart and soul of it is data. It all lies in the data that is being fed, whether in real time or pre-trained, right? So it's one of the reasons why uh, it's very important to get quality data trained on large scale, because it improves all the advantages and gives us better reasons to work with machine learning rather than regular computing processes. So let's move over to applications of applications of machine learning. Now, machine learning is obviously applied in multiple and an array of industries that we cannot even count, and a reasonable number of them are being discovered every single day. I mean, the general industries are already known in the areas of healthcare, transport, electricity, and the rest. But under these major industries, there are always subdivided areas that these technologies can be applied to. And anywhere you require decision making, automation, and innovation, I would generally say artificial intelligence can be applied, even though some not directly or as should I say should I don't know what the term to use, even though not directly or as fascinatingly as that's wrong, that people may make it seem. So it may be used in instances where it may not be as flashy exactly that most people want it to be, but it's actually solving a key core problem in that particular industry. We can use it in healthcare. Everyone is aware of this. Enhancing disease prediction, diagnosing conditions, and personalized treatments. So, you can use artificial intelligence to triage, meaning to ask certain questions and then determine the ailments that humans have in their body systems to a certain level of accuracy before there is immediate medical attention in order to save lives. You can use it to predict diseases based on certain parameters or key components that the model has been trained to identify. So let's say if a model has been trained to identify certain minerals that have to be present in the blood system, and in order to detect, let's say, cancer or a particular disease that affects a certain part of the body, machine learning models can be fed the blood through a right equipment and then scanned through a model to predict the exact disease, rather than before where it's normally where it has to be with um, should I say only human observation, which I wouldn't say humans are flawed, but to a certain extent, we are not as accurate. So the reason why machine learning has to be developed more and more is because if we can get it right, they will definitely be much more accurate than us. Because one of the key core advantages of, characteristics of computer systems is accuracy. But in the case of machine learning, the better the data, the more accurate your model becomes, right? So diagnosing conditions, I've spoken about that before, triaging, being able to determine what ailments people are going through in order to then administer at least first aid, or even aid doctors, laboratory technicians to discover what exactly the ailments that are plaguing people are about. So we've gotten to a scenario where you don't necessarily have to study and store so much information in your head as a medical practitioner. You just have to understand and learn how to work with tools, understand the human body, the particular immune systems that work for what, and when certain symptoms or parameters are given to you, you can work effectively with artificial intelligence models to try out exactly um, what ailment is plaguing a human body. So this is one of the applications. Next, we move into finance. So you can implement artificial intelligence in fraud detection. I recently saw a I would say a joke where someone convinced people he was Elon, but it wasn't real. It was just a comedy where he convinced people he was Elon Musk. And if they sent him $1,000, he would double it. And so they sent him 1,000, he did it, and then He told them to send $10,000, and when they sent the money, he didn't return it, obviously. So that's like a huge profit for him. Or credit card fraud, monitoring digital footprints of certain internet parties from certain locations with use of IP addresses and VPS tracking and all of that. So normally, these processes that would have to be analyzed manually and in a detailed manner by cybersecurity specialists or monitored in real time, which is actually very stressful and not feasible when you talk about the global market, right? Because in every single time zone, someone is awake somewhere performing a transaction or doing something that's very, very important. So with artificial intelligence that are automated, if you recall, we spoke about machine learning being a tool that can automate earlier. If you can automate with machine learning models, you can be able to detect certain digital footprints on the internet and then slow them down or pinpoint them to a particular location in order to stop fraud, find out fraudulent activities on certain websites, applications that are key to the economy, and improve the application of that particular technology. So that is another key application of machine learning. Then we'll go to e-commerce. So e-commerce is very, very important, especially when it comes to economies that are fully developed, right? In certain economies around the world, in countries that are still adopting, it's also growing. But in economies that are fully integrated, that have been integrated for up to 10, 15 years now, artificial intelligence is very good for product recommendations, right? And naturally, they already had algorithms, manual Python algorithms that were built to implement recommendation engines, right? For all these for websites and e-commerce platforms. But with artificial intelligence, you can train models to perform these particular recommendations automatically, and onboard particular take data from particular and specific users with those specific locations and feed them exactly what they need. Now, this particular product recommendation this particular product recommendation feature is one that has faced controversies in areas of data privacy and all the others. But in cases where data privacy and all that are not the issue, it's very, very useful. And I think it's something that we thought was only possible in areas of online stores. But I mean, when you now go into much developed places, in developed areas, and see that the use of product recommendations can also work in physical stores in areas of when a store is fully digitized, you and there's like an online virtual assistant guide when you walk into a very large mall, right? That can pinpoint product area sections based on user preferences to tour an individual around the mall without him knowing that he's being moved around the sections of products he's most likely to buy to improve customer patronage, right? So, like I said, the data area part of this always has controversies in the areas of privacy. So I won't speak much about that, but this is one of the applications, and if used rightly, would definitely improve the convenience of people shopping globally and improve trust. Now, natural language processing used in language translation, voice assistants, etc. I believe the very first implementation of artificial intelligence that humans were able to feel was in the area of voice assistants, and we didn't even appreciate them well enough. So, voice assistants have been around for a very long time, right? We've been working with Siri, we've been working with Alexa and the Google Assistant, and there have been applications of machine learning, right? Even though they weren't that advanced when they officially started, they were more of core AI systems then, but they're a very, very important part, including language translations. Now, there are certain applications or features in large applications where people from different native localities can speak to each other directly without any border now. Then autonomous vehicles in the areas of powering self-driving cars by recognizing objects and making real-time decisions. So I think the forefront company in this particular technology would be Tesla or some other companies we follow an autonomous with, where computer vision and convolutional neural networks in object detection are utilized to enable that um, autonomous vehicles can navigate through cities that are properly networked. That's the key word. Sorry, properly networked and mapped out without any incidents of accidents, and even grow to a certain level of accuracy that is unachievable by the average human driver. So the areas of use of computer vision and machine learning and through convolutional neural networks is a very, very, very important application of machine learning, because there's a huge rise in um, humanoid robots, autonomous vehicles, and all of that stuff. So this is a very huge application. Image recognition, such as facial recognition, security systems, medical imaging analysis, very important, because the traditional methods of image recognition and the rest were built based on facial features, which could change over time. So the utilization of machine learning in these features make it such that as parameters change, such as age, maturity, and all that, the systems will be able to still recognize based on patterns it has been trained on, and the growth and predictions of humans in terms of larger faces, wider faces, and beard sprouting and all that, to ensure that these systems remain sustainable and reliable. So it's a very, very huge application of machine learning. So now, this bootcamp is designed to talk about machine learning basics with Azure machine learning. So the first thing we're going to talk about is why train machine learning models in the cloud. This is a very important question. You can't speak about machine learning basics with Azure machine learning without understanding why we train machine learning models in the cloud. So everybody knows that in order to train a machine learning model, you require a unit with processing power, either a CPU or more preferably a graphics processing unit, which is a GPU. And if you have access to all the resources, computing power, you can train a machine learning model. But then you would do a global statistic and find out that there are multiple reasons why training locally or just working with the hardware you have available may not be sufficient. If you do a global statistic to find out people who have computers competent enough to handle small to medium models, you would find out that it's very low. Talk less of the models who are heavy enough that actually perform the utility that have the most impact on the applications we use today. Now those models are heavy, right? You can't have all the hardware to work locally on your server, and also you face a lot of issues with data corruption, loss, privacy, and all of that. So there is a reason why we train models in the cloud, and that's what we're going to talk about today. So training model in the cloud offers scalability. Now, the cloud offers virtually unlimited resources, allow you to scale your model training without being constrained by local hardware. So I believe anyone who has done some studying on the cloud, maybe your Azure EZ900 or even with any cloud-based provider, would have learned about the shared responsibility model, where the cloud providers have a responsibility to and their hardware and the speaking about the infrastructure as a services, platform as a services, and software as services. Whereas in infrastructure as a service, they have um or let's say software as a service. In fact, all the models where the cloud providers have a responsibility to maintain their hardware and ensure that it's functional and works at all times. And then you, the user, has responsibility to install software. Let's say in the areas of infrastructure as a service, install software, manage administrator roles, privileges, that is role-based access control, and every single thing that has to do with provisioning your resources yourself, right? So this is one of the advantages of training machine learning models on the cloud in the areas of scalability. And this is because you could basically just pay for more resources and you're granted them. You could pay for the use of graphics cards that you cannot afford uh, at a go to work on models, or would actually be too stressful or lack of non-convenience due to power and all other issues. You could pay for them online with more credits and then work with graphics capabilities far more powerful than you can imagine, all on the cloud. And the cloud allows you to scale your model training without being constrained by local hardware. Believe we should all understand what this means. So it's basically the same advantages we have when we deploy our regular resources to the cloud in terms of virtual machines, when we Dockerize and then manage with Kubernetes scalar containers. Basically, being able to scale on the cloud. So that's scalability. Now, faster processing. Cloud-based environments provide powerful CPUs, GPUs, TPUs, significantly speeding up the training process. I believe I spoke a little about this about with working on the cloud, you have access to models that getting locally may be difficult depending on where you stay. Because one thing we should always understand when it comes to technology is that you always have to factor in the global markets. And if you're in an area that's advantageous or privileged to have resources and everything at your disposal, you it may not be so in other economies. So let's say people who are in the United States could walk into a store and pick up a graphics card as far as they have access to a credit card or enough money for that. Whereas people in other parts of the world would have to place orders, wait for weeks, and all of that. So the cloud helps to ensure that you do not have to face such problems. So that's why everyone should embrace the cloud. Cost efficiency. Pay as you go pricing model means you only pay for resources that you use without needing to invest in expensive infrastructure. So you only pay for resources you use based on the magnitude of resources and the amount of time you spend on them. I believe most resources are built on an hourly basis and then according to the graphics capabilities, the RAM and storage that you go for. Collaboration. Cloud platforms allow for easy sharing of models, data, and experiments across teams. The cloud platforms are easy for sharing of models. You can basically curate workspaces the on Azure ML and then work with teams all remotely and build solutions without having to meet each other. So collaboration is one of the key things when it comes to the internet, the cloud at large. It's one of the main importances. So this is one of the whys. Then accessibility. Can access the environment from anywhere, making development deployment more flexible. So it's basically similar to collaboration. If someone else can work with you from another part of the world, I don't see the reason why you cannot access your own work from anywhere you are. As far as you have connection, a good internet connection and a computer, right? So next, we're going to talk about Azure ML. So what is Azure ML? Azure ML or Azure Machine Learning is a cloud service for accelerating and managing the machine learning project lifecycle. Machine learning professionals, data scientists, and engineers can use it in their day-to-day workflows to train and deploy models and manage machine learning operations, MLOps. You can create a model in machine learning using a model built from open source platforms, right? Such as PyTorch, TensorFlow, Scikit-learn, and MLOps on Azure ML enables you to monitor, retrain, and deploy models. You could also make use of build your custom models with Azure Machine Learning. So Azure Machine Learning is a cloud service, like I mentioned. So it's Azure's own cloud service for building and utilizing and working with machine learning models on the cloud. So Azure machine learning is for machine learning engineers, data scientists, data engineers, and software engineers slash developers, depending on how you choose to identify or your job role specifies. So machine learning engineers are basically responsible for designing and writing algorithms that train machine learning models to achieve the level of accuracy required and adaptability. Data scientists are concerned with data preparation, data analysis, a little bit of analysis, and working with libraries to ensure that when the data engineers build pipelines that are used to train models, it can work sufficiently and in the right way. Software engineers and developers are not left out, please. We can utilize Azure Machine Learning to build and incorporate existing AI features already into our applications by training models, custom models, whether large or small scale, to host and work on our applications to improve response time, throughput, and also reduce redundancy and all other um, errors or issues one may face, right? So we've spoken reasonably about Azure ML. I would like to open up the interface, would create a workspace, and then basically understand how the interface works, see how Azure machine learning works, and would basically call it a day for this beginner class. I believe, oh wait, or someone is, yeah. Okay, so I would move over to Azure Machine Learning, then share my screen again. So if anyone has any questions while I'm doing this, the person can basically ask, and I'll do my best to answer them. We'll have more people joining us. That's fantastic. Okay, I'll let them in. Okay, I'm seeing some questions. I'm seeing some questions in the comment section. Okay, I'll answer some of the questions now. So approximately how much does training of a model cost in terms of energy? Hmm. To be honest, training of a machine learning model, depending on the skill of the particular model, may vary. I am not particularly versed in terms of this, and I'm not sure why you'd want to know, but I think it's one of the reasons why I spoke about the shared responsibility model, where building on the cloud makes you not to have to worry about such, and you just have to pay and then utilize your models that are already deployed on the cloud and work with. So you shouldn't really bother about this unless you're trying to run a startup, let's say Nvidia. I think executives as Nvidia would really note and estimate how much running models cost in terms of energy, and they'll tackle it with bills or their own power supply. So that's fine. For someone who wants to work on machine learning and build his or her projects professionally, you should just bother about working and provisioning the resources on the cloud. I'm saying okay. Okay, someone already tried to answer. Yeah, depends on the skill. But for very small type of models, your PC will be sufficient. Yeah, that makes sense. That's fine. Okay, so I would open up Azure portal and then share my screen. Okay. Sign up process is always tedious. It's cool. Okay. And I'll share my screen now, and if you choose up, I'd like someone to signify so that you'll know. I'll know that I'm doing the right thing. I'll stop sharing this, share something else. So share. Yeah. Okay. So I believe I'm doing the right thing. Everyone should be able to see my screen at this point.
Yep.
Okay. Okay. So while working with Azure Machine Learning, you have to learn to provision the resources that are used and required to do this, right? So the first thing you have to do is to learn to provision a workspace, create a machine learning workspace in terms of, I think it's very similar to creating resource groups and all that stuff I would see. So it's fine. So we'll just go through it. So we can just say create a resource. I think we can just work with this from here. I mean, you could work directly from the studio or here, but it's fine. Just work with this. Okay. So I believe, okay, I'll just go back. I won't take it for granted that everybody here knows exactly how the whole Azure interface works. So we're going to go to create a resource and I'll type in machine learning here. I'll search for it. So this is Azure machine learning. Has a logo similar to that of, I'd say like a test tube, but drawn in an angular shape, and that's fine. So we can say we create a resource. Okay. I believe there are tutorials and articles designed to guide you through this, and I'll try to drop a link eventually, but I'll just guide you based on my own knowledge. But that's in case for anyone that wants to work later. Okay, so I'm a student ambassador, so my subscription runs in Visual Studio Enterprise subscription. It will be the same for any other. Uh, I can create a new resource group or decide to continue working with the one I've worked before. So I think I have a resource group for machine learning specifically. So we have the resource group. Next, we can say WGMIT ML. We can try to choose that to make this work. Okay, then we'll continue to move further. Then region. Based on my region, I'll choose East US as that is the closest to me. Then storage account. Okay, we believe that storage account is okay. Application insights. That's fine. Next, we move to networking. So, creating machine learning resource is one that you have to go through all the steps while doing that to be sure of exactly what you're doing. It's kind of much more advanced than just clicking review plus create and heading to the last section. So, we're going to leave it as public because, yeah, it's just for demo purposes. Then encryption. Okay. Okay, that's fine. We'll go to identity. I believe this was a bit different. Tax. Let me confirm something first. Okay, so we can then create the resource and then wait for it to be done. Okay, deployment is still in progress, so we'll still wait for it to be done. Mhm. Okay, now deployment is complete. We can basically go to resource. Okay, so now we have created a machine learning resource, right? You then see launch here. Now in Azure machine learning models are trained and worked with on a custom built platform by Microsoft called the Azure Machine Learning Studio. So you don't get to work with them directly here in your Azure portal like you would with other resources. Your machine learning studio is what you work with. So we'd have to launch studio, then I'll share that particular tab for you guys to see. So I'll stop sharing this particular tab and go for the studio. Mine is loading. Okay, so now I'll share my machine learning studio. Yeah, okay, that's fine. So I believe, okay, that's cool. So here we are at Azure Machine Learning Studio, and you can see at the top here that name I've given to it here, WGMIT ML. So now this particular interface is one you have to get used to, right? So here you can build, deploy, and train machine learning models. I know it's kind of like if anybody has worked with, well, not the same, this is actually better, but if you've worked with Google Colab before, you'll be familiar with stuff like this. So here, the first thing we're going to do is to try and create a compute, because the compute is very essential when you're working with resources on the cloud. So create a compute, select new, and continue. So basically, okay. So now this is a nice place to explain exactly what we're talking about in terms of why building on the cloud, right? So you can see here that we have virtual machine type in terms of CPU and GPU, right? I'm not allowed certain GPUs because I don't have enough quota. I'm not really looked into what this means, but basically, you can see that with 6 cores and two 14 gigabytes of RAM and 28 gigabytes of storage, I have 0.18 cents per hour. And as it goes up, it gets more expensive. And so for certain use cases, this is reasonably much more affordable and convenient than working locally. So this is kind of like what I was explaining earlier when I said it's much better to work on the cloud, especially when all the resources are not there. Also, for it's not for a large scale use case scenario like when you're running a startup or a company. That's fine. So we can just eventually shut all this down, but I'll just put this. This is just all for demo purposes so that one can understand how this works. So we can decide to still name our computes, because I mean, why not? After we're done with this, I believe I've provided all the parameters. Okay, then we can review plus create. Okay, so next is to review and confirm that all the parameters we've chosen are correct. And then we can just create one. So I think I'll drop some links from Microsoft Learn to the chat so people can read and understand more if they want to get an in-depth understanding of Azure machine learning, because it's pretty important, especially if you're used to working with models locally or with other resources. It's very important to understand why this and what it can do for you. So I think I'll drop one here in case you want to do some reading to study. It's fine. Okay, so back to this here. Okay, so our computer is still creating, right? So I'll just put some other links while I wait for that done. It's also important to note that your Azure machine learning provides you with the ability to work locally and also work on the cloud. It also provides you with a live Visual Studio Code instance that you can just work with on the browser in case you're used to working with Visual Studio Code environments and you're someone that likes to be familiar with exactly everything you do, right? So it's fine. You could also work with your models and build them with raw code, or you could work with AutoML depending on how you work. I believe AutoML is a feature that is very important and should be covered in the session where you'll be taking on building and deploying models with Azure machine learning. After this introduction and understanding and some reading, you understand the reason why Azure ML is what you should embrace when you want to work with machine learning and build models. Takes quite a while to finish this. Okay, so now the state has changed to running. Idle hour is set to 1 hour. So if it goes an hour without any activity, it goes idle so that you can consume, it can conserve resources and reduce the amount of billing that comes at the end of the month. So it's very important. Okay, so now there are so many features to work on with Azure Machine Learning. There's automated AutoML, there is jobs, there's data labeling, data sets that you can work with now to make things work, right? I believe in the building and deploying models class, you'll be covered and taught most of these concepts. Or I'll still drop resources where you can study and read to understand all of this, right? So let me find some resources and drop in the comments. Shit. Okay. Yeah, I just like what I just saw in the comments now. Yeah, Azure actually provides more services than Google Colab and more control over resources. Google Colab is kind of like something that was built and then handed over to highly technical people and say work, right? But Azure is like a full all-in-one suite, as Microsoft is known for delivering all their resources and solutions all at once. That's fine. So I've dropped links to Okay, someone asked, does the platform also have data sets or one must import data sets? Yeah, definitely. The platform has some data sets that are provided here by default, but my experience working with them, most of them were just basic. But getting data sets is not very difficult. I believe you can just go to Cargo. I don't know if anyone knows anything about Cargo, and import data sets to work with on Azure machine learning. I believe I was exploring some the other day when I was trying to understand. I would also drop a link in the group now. So you can see I've dropped the link of Cargo and data sets. Yeah, that's very cool. You can access data sets from there. You can work with and make so. Okay, so I believe I have guided you through the explanations of machine. Oh, okay. Yeah, that's really cool. Guided you through the explanations and concepts of machine learning, moved into Azure Machine Learning device to understand and guide you through the basics of machine learning with Azure, right? And I've dropped some resources that you can make use of and understand more about Azure Machine Learning. I sincerely wish I would have covered a lot more about this, but then when I checked the schedule, I saw that there's already a session that's scheduled with building and deploying models. And due to certain restrictions on my part, I wouldn't want to encroach into that, and also time resources available to me, right? So at this rate, I would just want to entertain any questions in the chat, or if you want to unmute your microphone and ask questions, I'll entertain them, and then we would close the session.
Yes. Can I ask a question?
Sure, definitely.
Yeah, there's something I've just seen you when you are running some part of, I don't know, when you're creating resources. I've seen something like 1 hour, and I don't know. Do we have some restriction when we're working on the Azure platform, or depending? Because I remember, like in Google Colab, if you set your runtime to be on a GPU or a TPU, you realize that it is bounded to some limitation of time. So what happens with the Azure platform?
Okay, so that's a very nice question. Like it was mentioned in the chat, Azure offers a lot more services. So the 1 hour time you're seeing there is basically a feature that helps ensure that resources are not wasted and compute instances are put into an idle mode when they go idle for up to an hour. So it's basically tracking your resources to ensure that you're working, and if you're not working, it puts them idle so that you don't waste resources and you're not billed for multiple hours. I I discovered that that's a very, very important feature when working with cloud resources generally, as most times, especially when we're working on demos, we tend to forget to shut down our resources, or you're working and then you lose power, you just want to recharge, you just forget it. And if it's a resource that is built heavily per hour, you would incur a lot of costs by the time you're back. So the 1 hour time you're seeing there is basically the amount of time it would perceive idle and then go into an idle state, which you can easily just awaken it quickly when you're working on when you're working in in Azure ML Studio. So it doesn't mean that you have a limit on to the amount of time you can use this. It's just in terms of when it's perceived idle, it's put to sleep, not shut down completely, but put to sleep. And you can just rewake it with the click of a button when your model is being utilized. So you have nothing to worry about. It's not restricted that much. So it's fine. I hope that answers your question.
Fine. My second question comes,
Yes.
when we're working on Azure platform, or let's say the way we sometimes build on Google, and we have to save our work, maybe to save our data set. on the drive to ensure we don't lose it whenever we go offline. So what happens in Azure? Does it also have the working environment where the dataset is used only during the execution, or does it also call for us to store our dataset somewhere?
Oh yes, definitely it does. That's a nice question. Like I mentioned earlier, it offers a whole suite of services. You can basically even forget and abandon your stuff, and functionality such as the one we discussed earlier where it goes idle and all that stuff and saves your work will kick in to ensure it saves you up. So it's designed to ensure the data sets you're working with, whether in terms of CSV files, that is comma separated values, or any other you'll be working with, will be saved and stored here on the Azure ML Studio, and you can resume and continue to work with when you're ready. You can also, like when you're working with Azure services with your family, you realize that when you want to work with models or create new resources, it would also bring the previous and recent resources you worked with, so you can either continue from them or reference them for work. So definitely, that's a feature and more that you would get here on Azure ML. So that's very fine. You have nothing to worry about there. I hope that's cool.
Fine, thank you very much. Actually, it's a very, very great opportunity for learning. I've been using uh, Google Colab, but I can see I can try Azure and not just try, I'll exploit. Thank you
Yes,
for reading my.
that'll be really cool. It's be nice to make a post when you eventually try it out and tag the program. So that'll be really cool. Would familiarize with you and share ideas too. That's cool.
It's fine.
Yeah, so I mean I'll be entertaining any more questions anyone has. I believe there should be a lot of stuff people want to ask about. Everyone's
Uh,
silent. I hope people are actually in this meeting. Okay, you can ask more, please.
yes,
I'll
let
be
me
happy.
just yes, let me just ask more, just a simple one, not very simple. Because we have talked of you've said within the 1 hour, it can sleep, but on a click it comes back online. Okay, meaning it resumes everything back. What happens with the runtime engine? Does it disconnect, or it will simply again go back to the GPU, or it will come back to your CPU immediately it disconnect after the 1 hour? What happens?
Okay, so the runtime will definitely continue. It's when it goes idle and sleeps, it basically just continues with the resources it was provisioned with. But when you try to activate it back, it's going to go back to the resources that it was working with initially, right? Provisioned. It's not coming locally to your locally provisioned resources, no. So it should just continue that way. Everything is basically automated and designed to just be seamless, right? And once you continue, your billing will continue to run. That is number of cents or dollars, depending on uh, the every single hour. So yeah, that's how it works.
That's fine. That's fine. Thank you.
Okay, so someone asked a question: do we get pre-trained models in Azure? And if so, how many pre-trained models we get in Azure? Definitely, you get pre-trained models in Azure. Like I mentioned when I was working with slides, right? I'll just take back there so that you can easily see. You have the pre-trained models that you're already used to, right? When working with, that is, if you're already used to working with machine learning models locally, you already have those models available to work with on Azure ML Studio, and you can build and train your own custom models. So definitely you have models that you can work with on Azure and scikit-learn all the models that you're used to. Definitely. Yes. TensorFlow, PyTorch. There's so many of them, open source and the rest. Sure. Okay. I'll still wait some more minutes for questions. If not, I will just greet everyone, bid everyone a good day, and end the session. Aswin, I hope I answered your question. I believe it's Aswin that asked the question. Oh, yeah, thank you, Aaron. Thank you very much. Yeah, thank you. We appreciate you for attending. So thank you, dear. Thank you, everyone. I mean, I'd like to connect with any more machine learning enthusiasts after this session. I believe in the what's on the group. So yeah, that would be really cool. I'll just notify myself so anyone can chat me up and we can connect. Yeah. So I believe at this point we can just basically close the session and everyone will have a good day. So yeah.
Please drop your email kindly.
Yeah, thank you so much, Kudoze Akanono. We really appreciate. Thanks for an amazing section. Like he said, he would reach out on the group chat, so you can always reach out to him and connect with him for those that have interest in machine learning and all. So that brings us to the end of today's session. Yeah, so more information will be shared on the group chat with the slides, the recording, and all will be made available on the group chat. Yeah. Thank you guys for joining in. Bye.
Bye-bye.
Bye.
See you.
Yeah.